Okay, so we're back in reinforcement learning, and what I'm going to discuss today is a way to sample using one distribution and be able to estimate some average from a different distribution. This will enable us to explore new policies while executing other current policies in the setting of the reinforcement learning. Okay, so I'm going to do this in an abstract way first, and then next time I'm going to talk about it concretely in the context of reinforcement learning. But keep in mind that we have here two distributions, P and Q, and one of them is the current policy, and the other is the policy we're not sampling. So these distributions, they represent a policy in the reinforcement learning setting. So once I decide how I make a decision, it's a probability distribution, and then there's the distribution of how the environment take me to another state, and overall that dictates a distribution of sequences of events, of states that I'm visiting in the reinforcement learning setting. Okay, so these think about them as policies basically. But this time we'll talk about it in an abstract way. Okay? And then we'll make it concrete. Also, to simplify the calculation, I'm talking now about a discrete distribution. So I just have a countable number of states, and each one of them is the distributions are defined on that state. So if you have positive distribution, positive probability for each of these states, x1, x2, and so on. Okay? If you as an exercise, think about the continuous case where this is a density function, and this is going to be integrals, and try to see if you can go to the same calculation. Okay, it's an easy exercise, just try it. Okay, so what I'm trying to say, I'm trying to sample, I'm basically trying to sample this average, okay? But I'm not working with this policy. I'm working with a different policy. Okay, so the magic is I'm going to sample using this policy and find the average for this policy.
Can you explain the notation? What f represent and x?
Yeah, f is just a function. Think about it as in our context, it's how much you get paid.
That's the reward function?
Yeah, that's the reward function for the entire history.
And x?
X is the random variable.
Mm-hmm.
And P is the distribution I'm using. So actually
you generate x.
Yes, so this is basically an average on the random variable with this distribution.
Okay.
So by definition, that's how it's defined, right?
Mm-hmm.
The problem is that I'm not sampling with P. I'm sampling with Q. Okay. So what I do is I write this, which means this is different than 0. Whenever this is different than 0, this is different than 0. Okay. If both of them are 0, it doesn't matter. And then I'm changing the places here. So you see this is an average of this function under Q. So basically this is another way to say average of f under Q. Okay? So what I'm doing is I'll sample under Q, and I'll calculate this, take the average, then I get an estimate of this average, but this is an estimate of this average because everything is equal. So that's the magic. I'm sampling using Q and get an estimate of P. And I need to know these qualities. So basically I need to know P over Q. And that will be the trick. The next time I'll explain how I know it in the reinforcement learning case without knowing P and without knowing Q. Okay? That's it.